Welcome to 11.1, which is simplifying radicals. Perfect roots are what we're going to look at today. Go ahead and put today's date in the top right-hand corner, and our target is that I can simplify radical expressions that are perfect roots. So to start out with, let's look at a radical. A radical we most commonly see, and we call him a square root, but there's more parts to him than just the bar itself. So we have a little n out here in front, inside the little part that sticks out of our square root bar, and then there's the guy inside of it. So the guy out here in front of the bar is called our index. The guy inside is called our radicand. And the bar is called a radical. So that's how radicals are set up. You have a little itty-bitty number in front of your radical, and that's your index. He's very important. We'll see more of him in a little bit. Then the bar itself is called your radical, and then the guy underneath the radical is called your radicand. So let's just look at as far as just identifying our parts. So if we have the example, square root of 4. Well, it's a square root bar. So much like a square has a power of 2, a square root bar has an index of 2. It's just hidden. So square root bar has a hidden index of 2. And then our radicand is the guy inside of the radical bar, and it's 4. And if we have a cube root of 8, well, our index then is 3. It's hidden. The only one it's shown here. The only time it's hidden is just on a square root bar. For cube roots and fourth roots and fifth roots, it'll always be shown. So the index here is 3, and the radicand is 8. So let's talk about those index numbers for a moment, because here we have an index of 2, and he's an even number. So an even index has one positive and one negative root. But there are no real roots for a negative radicand. So let's see an example of our even index. We'll go back to our square root we used up here. So square root of 4. Well, we already have a little bit of prior knowledge about square roots. We know that the number has to be the same factor. So if I try to break 4 apart into exactly the same factor, I can break it down to 2 times 2, because 2 times 2 gives us 4. So the square root of positive 4 can be positive 2. And remembering that rule that they have to be exactly the same number, I could put negatives on here and say negative 2 times negative 2 gives us positive 4. So the square root of 4 could give us a positive 2 or a negative 2. And sometimes we'll see it written with a plus or minus like this, showing that it could be a positive or a negative 2. Alright, and then let's see one for the negative radicand. So if I have a negative square root of 4, square root of negative 4. So if I have the square root of a negative 4, Once again, we come over here, and we're going to try to break down our 4. We know he's made by 2 and 2. But 2 times 2 gives us a positive 4, and I need him to be a negative. So that doesn't work. And remember that to be exactly the same number, so if I put a negative on this guy, I have to put a negative over here on this 2. So negative 2 times negative 2 still gives us positive 4. I can't make a negative with exactly the same 2 numbers. So anytime we have the square root of a negative, or we take an even index of a negative radicand, we say there are no real roots. Now, that's for an even index. Let's look at the odd index. So odd index has one positive root for a positive radicand and one negative root for a negative radicand. So basically it just does what the guy on the inside the radical does. So if it's positive, it's going to be positive, negative if it's negative. So if we kind of base it on like the same thing I did earlier, if I take the cube root of a positive 8, then we know we can break 8 down into 2 times 4, and then 4 can break down to 2 times 2. So I have 3 2's here. So the cube root of 8 has to be a positive 2. The same way if I take, change colors here, the cube root of a negative 8, well, using the last example we did, we know 8 can be made apart by 3 2's. And remember, if I make this first one a negative, I have to make all 3 of them negative. So negative 2 times negative 2 times negative 2. So negative 2 times negative 2 makes positive 4 times negative 2 again gives us a negative 8. So the cube root of a negative 8 is a negative 2. Now, we are going to look at simplifying them out, much like how we are here in our examples for our even index and odd index. But I want to review the perfect squares first. Sorry about that. I had slightly out of order. I had to slide it down and change it. Before we get to our perfect squares, let's look at this last little note. It says the root of 0 is always 0. And basically, that's true because 0 times 0 gives you 0, so the square root of 0 is going to be 0. The cube root of 0 is going to be 0. So the root of 0 is always 0. Now we can move on to our perfect squares. And this just goes back to kind of like what we've listed out before. We're just going to list out some perfect squares. That way, as we get to some of them, we can recall them a little bit faster. So perfect squares are your 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'm going to go on and do the 11. So 11 squared is 121 and 12 squared is 144. So there are your perfect squares. Okay, now our steps to simplify radicals. Our first step is to give each individual number and variable their own radical. So we're going to make everybody independent, give everybody their own radical. Step 2, we're going to take the root of the number. Then step 3, we're going to divide the variables, exponents, by the index. So divide exponents by the index. And just a reminder, square root has a hidden index of 2. And lastly, we're going to make sure our answer is written in simplest form. So let's see some examples. Example 1 says to use a calculator to approximate to approximate each value to 3 decimal places. So our first example is a positive or negative square root of 77. Now this sign in front just tells us my answer could be a positive or a negative. So You don't really do anything with him but just drop him down to your answer. So plus or minus. Now, square root of 77. So put in 77, we're going to take the square root of him, and he's 8.7749. Now it says around 3 decimal places, so that would put me at the 4. And that 9 is going to round up my 4 to a 5. So my answer is going to be 8.775. Okay. Our second example is the cube root of a negative 21. Now, what we're going to have to do is just say I can take a negative radicand as long as I have an odd index, and I do. So if my radicand's negative, my root's going to be negative. And then we just take the cube root of 21, and that's going to give us 2.7589. So that 9's going to round up my 8 to a 9. So 2.759. Try that box again. There we go. And our last one has the fourth root of a negative 402. So we check. So we check out our third example and our, don't know why I opened that one up. There we go. So we check our radicand. It's negative 402. And our index is an even number. It's 4. So I cannot take the root of a negative radicand if my index is even. So for this one, all we have to do is just write no real root. So I can take a negative, so I can take the cube root of a negative 21 because our index is odd. I cannot take the root of a negative 402 because our index is 4. All right. So let's see some that we actually simplify out. So once again, that sign in front, plus or minus, I'm just going to drop him down. Now this is where our notes come into play. It says step 1, we're going to give everybody their individual radical. So 25 and x to the 4th, they're going to be independent, and they're going to get their own radical. So square root of 25. And because they're side by side in here, that means they're being multiplied, so I have to put times square root of x to the 4th. Once again, that symbol just drops down, a plus or a minus. And then we take the root of our number, so the root of 25, square root of 25 is 5, times. And then whenever you do take the radical of it, it kind of disappears. So the square root of 25 is just 5, no radical. So I'm going to mark him out so we don't get confused. And then it says for our variable in step 3, we're going to divide variable's exponent by the index. So remember, square root has a hidden index of 2. So I'm going to divide its exponent by 2, and that makes the radical disappear. And x is going to be 4 divided by 2 is 2. Now the last step is make sure it's written in simplest form, and since it's 5 times x squared, I can just say a plus or a minus 5x squared. There we go. That's our final answer. So example 5. We have the cube root of 64, x to the 15th, y to the 12th. So once again, step 1, we'll give everybody their own radical. So the cube root of 64 times the cube root of x to the 15th times the cube root of y to the 12th. So cube root of 64 is 4. Now for my variable, sorry, backtrack for a second. So when we take the cube root of 64, the radical disappears and it's just 4. All right, then I take the cube root of x to the 15th. My variable's exponent gets divided by my index of 3, so the radical also disappears. And we get times x. 15 divided by 3 is 5. Times, then same thing here. My exponent of 12 gets divided by the index of 3, so radical disappears, and y is 12 divided by 3 to the 4th. Now once again, 4 times x to the 5th times y to the 4th is just 4, x to the 5th, y to the 4th. Okay, example 6, we have a negative square root of 49 x to the 8th. So once again, the sign in front just drops down, so negative. We give everybody their own individual radical, so square root of 49 times square root of x to the 8th. So negative symbol drops down again. Square root of 49 is 7, so radical disappears, and I should get 7. Then my exponent, 8, gets divided by the index of 2. So radical disappears, and I get x to the 8 divided by 2, 4th. And negative 7 times x to the 4th is negative 7 x to the 4th. Example 7 has a negative square root of y plus 2 to the 8th power. Now once again, that negative symbol in front, we're just going to drop him down. Now this has a parenthesis, so I'm going to treat the parenthesis like I would if it was just one variable or just one number. So if you notice, that parenthesis has an exponent of 8. So the only thing I have to do to take the square root of this is to take my exponent and divide it by the hidden index of 2. So my radical disappears. I'm left with y plus 2, still in parentheses. And then we say 8 divided by 2 is 4. That's as far as we have to go. Then our last example, we have the 4th root of 81 a plus 1 to the 12th. So it's a lot like example 6 and 7 combined. So it's the 4th root, and then I have two things in here. I have 81 and a parentheses. So I'm going to take the 4th root of 81 times the 4th root of my parentheses. So we keep the parentheses all grouped together like he's just one big thing. So then we say the 4th root of 81 is 3 times. Alright, then we take the 4th root of a plus 1 to the 12th. So I'm just going to take my exponent and divide it by my index of 4. So the radical disappears. And I get a plus 1 to the 12 divided by 4 is 3. And then we just write out my answer in simplest form. 3 times a plus 1 to the 3rd power. There we go. And that finishes up for simplifying radicals.